Yeah, good evening all. Now I am going to explain about some more problems on transformers. Okay, next 41st question. A 4 kVA, 400 by 220 volts, 200 volts single phase transformer has leakage impedance of 0.02 plus J 0.04 per unit. This leakage impedance in ohms when referred to HV side. That means from the given question what is given, impedance per unit is given, we need to calculate impedance in ohms. Okay, when referred to HV side, that means from the given rating 400 by 200 volts, voltage rating high voltage side will be 400 volts, right? That means the formula will be Z ohm is equals to Z per unit into kilovolt square or voltage square divided by kVA rating or MVA rating. Here is given voltage and kVA rating, right? That is Z ohm is equals to Z per unit into voltage square divided by volt amperes or kilovolt amperes, right? Z per unit is given as 0.02 plus J 0.04 into kilovolt. Voltage will be 400, right? That is 400 square divided by 4 kVA, that is 4 into 10 to the power 3. Okay, then if I simplify that equation, I will get the answer as 0.8 plus J 1.6 ohm is the correct answer. Yes, now see here from the given options, first option is 0.8 plus J 1.6 ohm is correct. Next, 42nd question. As the load on a transformer is increased, the core losses is nothing but constant losses or iron losses. Okay, these losses are always constant. Why? Because hysteresis losses and eddy current losses are nothing but core losses. Okay, those losses are depends upon supply voltage and applied frequency. Okay, those losses doesn't depends upon load current, hence these losses will be remains constant. That means 42nd answer will be C is correct. Next, for the system shown in figure, the phase relation of current with respect to voltage VAB is, okay, already we know the phasor diagram of a transformer, right? Here load is pure inductive load. Pure inductive load means in case of inductor, current leads voltage by 90 degrees. That means I2 leads E2 by 90 degrees. Okay, V1 is the applied voltage, right? And V1 is equals to minus E1 from Lenz's law, right? E1 and E2 are both are in phase. Here load is, the problem is given load as inductive load. See the problem, you can see here load is given as pure inductor. In case of pure inductor, current lags voltage by 90 degrees. Current lags voltage by 90 degrees in case of pure inductor. Now see here current I2 is lags E2 by 90 degrees. But in the problem what is asking, current I with respect to voltage VAB. VAB is nothing but primary supply voltage, that is V1. Okay, now see here for that purpose you need to draw the phasor diagram. This is V1. Okay, next I mu is the magnetizing component of current which is required to produce the working flux in the transformer core. Right, now see here in this phasor diagram, current I2 lags E2 by 90 degrees. But when we take reference from V1 to I2, right, here I2 leads V1 by 90 degrees. I2 leads V1 by 90 degrees. When we take E1 or E2, I2 lags E2. That means the current will be leading. That is I with respect to voltage VAB is 90 degrees leading. That means 43rd question answer will be B is correct. Next, 44th question, direct theory question, you can read it. Next, 45th question, if the applied voltage of a certain transformer is increased by 50% and the frequency is reduced to 50%, assuming that magnetic circuit remains unsaturated, then the maximum core flux density is, already we know that B maximum is directly proportional to V by F. Now see here in this case applied voltage is increased by 50%. That means V is changes to 1.5 times of supply voltage. Next, frequency is reduced to 50%. That means F2 is reduced to 0.5. Just see here, B maximum is directly proportional to V by F. Then B maximum is directly proportional to V is increases to 50%. Okay, assume first starting percentage 100, then remain next 50% increase means 150%, that is nothing but 1.5 times of V. Next frequency is reduced to 50%, that means 0.5 into F. Then B maximum is equals to 1.5 divided by 0.5 is nothing but 3 times of V by F ratio, right? That means B maximum will be 3 times of previous case. That means changes to 3 times of the original value. That means 45th question answer will be A is correct. Next 46th question. In a transformer, low voltage winding is placed near the core in case of concentric winding so as to, okay, in case of concentric winding procedure, insulation cost first point is it will reduces insulation cost. Okay, first we will see the given options. Reduce the leakage flux. Okay, leakage flux will be reduced by using interleaved winding procedure. In case of co-type transformer, concentric and interleaved winding procedure is used. Because of the concentric winding procedure, cost of insulation is reduced. Because of interleaved winding procedure, leakage flux is reduced. That means first option is not correct because of concentric winding procedure. That means first is not correct. Second one, reduce the insulation requirement, that is second point is correct. Next, reduce the risk of voltage shock in case of insulation breakdown, right? That is also correct, same as second. Next, fourth point, reduce the core losses. Okay, that is no way related to core losses, right? That means correct. Fifth point is reduce the total conductor material. Okay, why? Because first we place the low voltage winding, copper requirement will be less, hence it will reduces total conducting material also. That means second and third and fifth options are correct. That means from the given options, fourth option is correct, 2, 3, 5. Next, 47th question. Can a 50 Hz transformer be used for 25 Hz if the input voltage is maintained as constant at the rated value corresponding to 50 Hz? That means what is given? Frequency is reduced to 25 Hz, but input voltage is remains constant. That means V by F ratio here it is variable, right? When V by F ratio is variable, what is given in the options? Yes, since voltage is constant, current level will not change. First option, that is not correct. Second option, no, flux will be doubled, which will drive the core to excessive saturation. Now see here frequency is reduces, right? When frequency is reduces means B maximum is increases. See here, see the solution. When frequency is reduces to half, that means 0.5 times of supply frequency when compared to first case. That means when frequency is reduces to half, what about V by F? 2 times of V by F, right? That means maximum flux density will be 2 times of original flux density. That means from the given options, flux will be double. B maximum phi equals to Bm into An, right? That means flux will be doubled, which will drive the core to excessive saturation. That means second option is correct. Next, 48th question. Voltage applied to the primary of a transformer is kept constant, but its frequency is decreased under this operation. When frequency is reduces, what happen? B maximum is increases, right? When B maximum increases means magnetizing current also increases. Okay, when magnetizing current increases, what about hysteresis losses? Hysteresis losses also increases. Why? Because when frequency is reduces, when V by F ratio is not constant. Better you can see the solution here. When V by F ratio is not constant, right? When supply frequency is reduces, B maximum is increases. B maximum increases means magnetizing component of current or excitation current is increases. When frequency is reduces, hysteresis losses also increases. Hysteresis losses increases means iron losses are increases. That means if we increase the if we reduce the supply frequency, magnetizing component of current and core loss component of current both are increases. Okay, that means 48th question answer will be D. Next, in a transformer, if primary leakage impedance is neglected, okay, then magnetizing current lags the applied voltage V1 by 90 degrees. Okay, magnetizing, that means Im lags applied voltage by 90 degrees, that is from no load phasor diagram, that is correct. Next, core loss current lags V1 by 90, that is not correct, right? That is core loss, that is IW or IC is in phase with the V1. Second option is not correct. Next, exciting current lags V1 by 90 degrees. Exciting current lags, exciting current means no load current, that is also not correct. That value will be approximately 75 to 80. Next, exciting current lags V1 by about 90, right? 75 to 80, that means, so fifth one is correct. Next, fourth one, see the fourth one, core loss current is in phase with V1, right? Previously I discussed this point, right? Core loss current is in phase, that is IC or IW is in phase with the V1, that means 1, 4, 5 is correct. Next, sixth one, magnetizing current lags V1 by about 80, that is not correct, exactly 90, that means 1, 4, 5 are correct. That means for 49th question answer will be A is correct. Next, 50th question, a transformer secondary is connected to pure resistive load. Resistive load means UPF load. The power factor on the primary side will be, okay, that is nearly UPF, okay, and lagging in nature. That means which one from the given question 50th answer will be near about 0.95 lagging is correct. Next, 51st question, if supply frequency in a transformer is doubled, okay, supply frequency is doubled, that means voltage remains constant, that means V by F ratio is variable. When V by F ratio is variable, hysteresis losses is depends upon directly proportional to V whole power 1.6 divided by F power 0.6, and eddy current losses are directly proportional to V square, right? When frequency is increases, hysteresis losses will be reduces. No change in eddy current losses. That means from the given options, hysteresis loss is reduces, right? From the given options, the answer is fourth one is correct. Okay, remaining we will see in next class. Okay, thank you all.